with P5A5, and there is one that is related with PAAA. Okay? What are the signs? You see P5, this is a positive contribution. PA is going in the opposite direction compared to 1x, and 1x is positive like this, so you have a minus sign. And, of course, you have forgotten this. You still need to consider this. What is R? What is R? This is the reaction, we have called that, of the gas on all elements like a blade that you have here. But the system we are considering here in the external forces, this is the air or the gas. So this is in the external forces, the force on the air, and the force on the air, this is minus R. Okay? And so you can say that R is equal to what? And you put R on this side, you see that R, this is A5 P5 minus PA AA plus M dot F V5 minus is plus, I move it in the other term, so minus M dot VA. And this is the reaction of the gases on all components that you have inside the engine. And we still need to consider this force. That must be also considered. This force, what is it? You can see the engine as two different ways. The engine, globally speaking, it can be from AA, down to A5. It can be this type of engine, or it can be this type of engine with AA larger than A5, or in this case, AA that is smaller than A5. We are just considering PA, so PA is perpendicular to the surface. This is PA, this is PA, and in this case, this is PA, and in this case, this is PA. Everything is symmetric, of course. I'm not a very good drawer. What do you see? And always the 1x is positive like this. 1x is positive in this direction. So the direction of the thrust. What can we see? We see that if you consider FPA, this is what? This is the integral between AA and A5 of PA ds. So we see that PA in the axial direction, has a contribution that is positive. It's PA is going to the left, let's say, and the integral will give you AA minus A5. This is the FPA in this case. The FPA in this case, this is the same equation, the integral between AA and A5 of PA ds. Here, PA has in the x direction a negative contribution. You see PA is a minus PA, and the integral of AA minus A5 will be equal here to A5 minus AA, and this is the equation of, this is the equation of FPA. And you see that FPA has as an equation PAAA minus A5, you see PAAA minus A5. So you can, if you add FPA here, FPA, this will be plus PAAA minus PAA5, okay, minus PA5. And what do we see? The sum here. This is what we have called a thrust. And there is one term that is disappearing. This is minus minus PAAA plus PAAA, this is disappearing, and you see that these two terms will be combined, and so the equation of the thrust is becoming, you see that the equation of the thrust is becoming m dot plus m dot f v jet, v5, minus m dot va plus a5 minus p5 minus pa. Plus p5a5 minus paa5. This is the equation that I wanted to have. So I have demonstrated the equation of the thrust. And why do I show that now only? Because I could have done that before. This is because I will take the analogy between what I have explained here and there with the thrust, with the d-additive. Indeed, the d-additive, this is in fact a flow that is like this, between the section AA and not the section A5, but with the section AI, with the section AI. And I have also something similar. So I have a pressure here outside that is acting as what I had shown before. So I have a term that is a P5 minus PA, but it's not P5 here, it will be P0, and here PA. I have also a mass flow rate. Of course, it will be the same there and there is no m dot f. And I have a speed, which is here VA, and a speed that has decreased, that is now here V0. And so, if you take the analogy between the thrust equation and the type of flow we have between the section AA and the section AI, you can say that the d-additive will be equal to what? M dot multiplied by not V5 but V0. I say V0 and I write something else, minus m dot VA, so minus VA, so be very careful with the notations because it's 0 and A, and the term which is plus A5 P5 minus BA. Of course it's not P5 but it's P0 minus PA, and it's not A5, this is A0, or better to say AI. And so we see that very easily we can obtain an equation that is enabling us to compute the additive drag. You see that the additive drag is the mass flow rate, and this is a bit strange because the additive drag is, as you can see, proportional with the mass flow rate. We are outside of the engine, and we have a term that is proportional with the mass flow rate, and this is a bit strange. And just multiply by V0 minus PA plus P0 minus PA divided by AI. What will I do with that? I would like to understand. I would like to understand what I have found. And so, you know, in aeronautics, we are keen, we love working with non-dimensional parameters. And so what will we do? We will write that that the drag additive, the additive drag, can be also written as the other drags as a 1/2 rho with an additive, with a drag coefficient multiplied by the speed square multiplied by a certain surface. This is always the way we have written a drag. 1/2 rho CD V square multiplied by a surface. Which ones in the case we are considering? Of course, you will take rho A, because this is, let's say, the reference, and this is what you have at the entrance of your system. If we speak about the additive drag, in fact, we will call the CD additive. So this is a new CD. In the past, you have discussed about the CDI, about the CD0. There is also the CD additive. The flight speed, you will take the flight speed of the aircraft square. And of course, you need also to consider a surface. And which surface will you take? You will take, of course, the surface AA. Okay? You will take the surface AA. And you see that CD additive is in fact equal to D additive divided by 1/2 rho A VA square multiplied by AA. And so you can also write that CD additive is this rho A VA square AA, and this is m dot V0 minus VA plus AI multiplied by P0 minus PA. This is the equation of the CD additive. And I would like to understand this CD additive. And what is, of course, the reaction you must have? CD additive. I'm in a course on aircraft engines. CD additive is a non-dimensional parameter. This is non-dimensional, so I write it function of two other non-dimensional parameters. This is the, let's say, automatic reaction, the instinctive reaction you must have. Non-dimensional parameters, so it's a function of two other non-dimensional parameters. And that will make the rational easy. It will make you thinking very quickly, then this. Which one? Whatever you want. Of course, what will you take? The Mach number, it is present here. You know that 1/2 rho A VA square, this is also equal to 1/2 gamma PA MA square, so the Mach number is there. And with what is the other one you will take? Of course, this. You will take AA divided by AI or AI divided by AA. Normally you will take AA divided by AI because AI is fixed and AA is changing. Maybe you will see that some people will write AA divided by A0. Normally it's AI. A0 was not really defined. So